On. Thank you. Alright. So, what we want to do today is we're going to prove trig identities. So the idea is that if you have an equal sign, this left-hand side will equal the right-hand side. It doesn't look like it yet, but they are equal. If the book or any particular problem puts the equal sign here, then you know they're equal. So we have to make them equal. So we've got to do a little bit of work. So we can either choose to work on the, what I would call the left-hand side, or we could choose to work on the right-hand side. But if I look here, it seems like the work really needs to be done on the left-hand side. The right-hand side is already down to sine squared, so my guess is if I work on the left-hand side, I should be able to get something that says sine squared. I want this side to eventually say sine squared. Okay, so let's figure it out. So probably what I might do is distribute cosine times secant and cosine times cosine. So let's go ahead and try that and see what we get. So we'll have a cosine theta secant theta minus a cosine squared theta. Okay, and let's see if that does equal a sine squared theta. In fact, I think it does. Okay, now, all right, I've got something, but what I ought to do is really take a look at what secant is. I know from my identity sheet that secant is really 1 over cosine, so I'm going to rewrite my secant as a 1 over cosine. Okay, so I'm going to go cosine theta, and I'll multiply this and make it a 1 over cosine theta minus a cosine squared theta equals a sine squared theta. So all I've done so far is I distributed, gave me a cosine secant, and gave me a cosine squared. After I distributed, then I found an identity. I know that secant's 1 over cosine. Okay, now actually I see quite a bit. Things are going to start to happen real quick. My cosine should cancel, right?
Yeah.
And then I'm left with a 1 minus a cosine squared theta equals a sine squared theta. Now at this point you have two choices. You really do, but I'm going to take the easier choice. You could either make the 1 minus cosine squared into a sine squared, because that is right there. You've got a 1 minus cosine squared equals a sine squared. Or you could make the sine squared into 1 minus cosine squared. The simplest form is really just to change this one here into a sine squared, and then you're done. So I'll change that one into a sine squared. So I have an identity. Sine squared theta is equal to a sine squared theta. You have an identity. If the left-hand side is exactly equal to the right-hand side, you're done.
On this one it has just the cosine, and that one has the cosine squared.
Right.
Does that make a difference?
Show me, I guess
Oh, I probably just wrote that wrong.
you might have. There you go. Yeah. Okay, number 2. All right, this is the one that we saw in the book, right? So we want to do, if it says that it's equal, they are. We have to make them look equal, right? At this point, they don't look equal at all. I can either work on the left-hand side, or I can work on the right-hand side. The left-hand side looks pretty simple, so my guess is most of my work, because, I mean, think about this. If you need to make this tangent secant look like this, you'd have to make it more complex, right? This one's complex. We're going to try and simplify it. So I'm going to go for the one that is going to take the work, which hopefully simplify down to something little, okay? So I got a fraction minus a fraction, so I'm going to think about a common denominator. I need to multiply the first fraction, this one here, by a 1 minus a sine of x, all over a 1 minus a sine of x. And I'll multiply this other one by a 1 plus a sine of x over a 1 plus a sine of x, okay, to get a common denominator. Okay, so what is my common denominator? Let's just write that down. My common denominator really is a 1 minus a sine of x and a 1 plus a sine of x. Okay, we'll write that down. That is the denominator. We only write it down once. A really easy example above, if you have 2 sevenths plus 3 sevenths, you only write down the 7 once, and the same thing. Here's my denominator, 1 plus sine, 1 minus sine, same thing on this side, but it is a common denominator, so you write it down once, because it is the common denominator. Now, what happens on top, on the numerator? Well, we'd have a 1 plus sine times a 1, which is a 1 plus a sine of x, minus, we're going to have, and the easiest way to do this is just to distribute the negative through. We'll get a negative 1, and you're okay with a positive, we'll get a positive sine of x, okay? Because I've got the negative times the negative makes a positive sign. Okay, now It still needs some simplification. I don't have it looking like a 2 tan secant. It's not there yet. So what I want to do is simplify this whole. The 1's obviously cancel, right? So then I'm left with a 2, because sine plus sine, 2 sine of x over. What you got?
Is this for next week? Because he's passing them out now.
I'm going to teach that. So
Oh, today?
Yeah, yeah.
All right.
Okay. So, and then this is going to FOIL. This should FOIL into a 1. Okay, watch this FOIL real quickly. I get a positive sign, a negative sign. You okay with those canceling? I get a positive sign, a negative sign. Oh, I'll do it. What the heck? Plus 1 sine of x minus a 1 sine of x minus a sine squared of x. Okay? How am I doing? Let me back up. I distributed. My 1's canceled. Yeah, I distributed 1 and a positive sign. My 1's canceled. Sine plus sine is really 2 of them. I've got a sine plus sine makes 2 sines. On the bottom, what I recognize, what I see right here is I know this is going to be a 1 minus a cosine squared. I saw that. I'm going to show you why it's going to be a 1 minus sine squared real quick, because if I do FOIL it, I get a 1 sine, I get a negative sine, and a negative sine squared. Then these two will cancel each other out, okay? And I'm left with a 1 minus sine squared, okay? So let's see what I have. I have a 2 sine of x over a 1 minus a sine squared of x. But this 1 minus sine squared is an identity, right? That's an identity. I can find that on my sheet. So a 1 minus sine squared is equal to a cosine squared, right? 1 minus sine squared is a cosine squared. Okay, so let's rewrite this as a cosine squared. So I've got a 2 sine of x over a cosine of x. Well, that's all supposed to equal a 2 tan of x secant of x, right? Yes, it is. Thank you, Paige. It is. So now what? Well, somehow we want to make it look like this. So, and I'm running out of room, but I can probably scoot this page up a little bit. I need it to look like this. Well, what I need to know is a tangent. What I know is a tangent is a sine over cosine, right? So let me rewrite this as a 2 sine of x over a cosine of x times another cosine of x. Thank you, Paige. I wouldn't be able to get that without the squared, right? So I made the cosine squared into a cosine cosine. The reason I want it, now you're like, what in the world did he do? The reason I need to do this, I need this to have a tangent. Well, there's my tangent right there. By breaking this up into cosine cosine, that is my tangent, right? And then I would also have a 1 over cosine, and over cosine is a secant, right? So finally, I'm going to rewrite this as a 2 tangent of x. 1 over cosine is a secant of x, and so I get an identity. 2 tangent of x, secant of x is equal to my 2 tangent of x. Yeah, Nikolai.
Where does the 1 that goes over the cosine come from?
Right. So, you know, anytime you have a fraction, you can always have a 1 on top. I mean, I put the 1 because 2 times 1 is 2. You with me?
Yeah.
So, I mean, by putting the 1, it just helps me a bit. But we definitely 2 times 1 is 2. So I didn't change the problem at all. I just made it so I could make that a secant. Okay?
Okay.
All right? Guys ready to turn the page? All right. Okay, so next one. I've got a cosine over 1 minus sine times a secant plus a tangent, okay? So somehow they are equal, but somehow we've got to have this side equal this side. So I'm thinking probably the first thing I want to do is maybe change my secant into a 1 over cosine. Might change my tangent into a sine over cosine, and that might get me somewhere. Let's give it a try. So,
Okay, so we're going to do the right-hand side?
yeah, let's manipulate the right-hand side, see what happens. And if I'm wrong, then we'll come back and do something on the other side. Sometimes you have to do both. Let's check this one out. In fact, I think on this case we might have to do both. Okay, so then I'm going to have a 1 over a cosine of x plus a sine of x over a cosine of x. Oh, I like that. I've got a common denominator already, don't I? So then I get a 1 plus sine of x over a cosine of x equals a cosine of x over a 1 minus a sine of x. Okay. Now they're not the same yet. So somehow I've got to go ahead and make this side equal this side. Well, All right, what kind of trick do I have up my sleeve to do this one? Well, what I might do with this one is I might multiply this one by, and it's a trick I happen to know that I'm going to pass on to you. Aren't you lucky? If I multiply this by 1 plus a sine of x, and I multiply this by 1 plus a sine of x, how is that going to help? I'm going to get a cosine of x plus a sine cosine plus a sine cosine of x all over a, you ready? A 1 minus a sine squared of x. Okay, you see the 1. I skipped a step. I knew the negative sign of the positive sign would cancel. I skipped a step. I did. I went 1 times 1. And I didn't do the negative sign, positive sign, because I knew they were going to cancel. You okay? I thought how they were going to cancel. You guys see that? I got a negative sign of x, a positive sign of x. I would have canceled. I just saved myself a step. Now, how does that help me? Well, I think this is an identity, isn't it? Isn't that an identity? So what is a 1 minus sine? Well, 1 minus sine is a cosine squared, right? So I'm going to change this into a cosine squared. So I'll have a cosine of x plus a sine of x cosine of x all over a cosine squared of x. Now what?
Change it into cosine on the bottom. And you can cancel out the cosine.
Yes, you are so right. I'm going to do it differently. You are 100% correct. 100% correct. Let me do it differently. I'm going to common factor out a cosine. Let me common factor out a cosine. So if I put a 1 here, you'll see the 1. So if I common factor a cosine of x, I will have a 1 plus a sine of x over a cosine squared of x. And this is what Jose was saying. He saw the cancel the cosines, right? And now you definitely see the cancel the cosines, right? So this cancels, and then what I'm left with is a 1 plus sine of x over a cosine of x. And guess what I have over here? I have the same thing. There it is. They are equal, aren't they?